Let me explain an example of density theorems. We need some preparation. Let me introduce a function called Euler's tangent function phi. Here is the definition. Phi of n is equal to the number of integers k between 1 and n, which are relatively prime. Here, relatively prime means the greatest common divisor of k and n is equal to 1. For example, if n is 10, there are 10 integers from 1 to 10. Among these integers, only 1, 3, 7, and 9 are relatively prime to 10. Since there are 4 integers between 1 to 10, which are relatively prime to 10, we have phi of 10 is equal to 4. Euler's tangent function phi is number theoretic in nature. Here is a table of Euler's tangent function phi n. For example, phi of 4 is 2, and phi of 7 is 6. We have already seen phi of 10 is 4. This function has many beautiful properties. Let me explain one of them. Suppose that n is a given positive integer. Consider a positive integer k dividing n. Then the sum of phi of k for all such k is equal to n. Let me give you an example. If n is 10, there are 4 positive integers k dividing 10, namely 1, 2, 5, and 10. Then take the sum of Euler's tangent function. Phi of 1 plus phi of 2 plus phi of 5 plus phi of 10. It is equal to 1 plus 1 plus 4 plus 4. It's 10. It is not by accident. It is true for any positive integers n. Let me explain why this equality holds true. Consider the case n is 10. Consider 10 fractions from 1/10 to 10/10. Of course, some of these fractions can be simplified by dividing the numerators and the denominators by the greatest common divisors. For example, 2/10 is equal to 1/5. 5/10 is equal to 1/2. But 3/10 cannot be simplified because 3 and 10 are relatively prime. There are 4 fractions with denominator 10. These were 1/10, 3/10, 7/10, and 9/10. Recall that Euler's tangent function phi n counts the number of integers relatively prime to n. Therefore, among these fractions, the number of fractions in lowest terms with denominator 10 is equal to phi of 10. The same is true for any k dividing 10. If k is 5, the number of fractions in lowest terms with denominator 5 is equal to phi of 5. Phi of 5 is 4. Now the miracle happens. How many fractions are there? Of course, 10. Therefore, phi 1 plus phi 2 plus phi 5 plus phi 10 must be equal to the total number of fractions, which is 10. This explains the equality. By the same reason, we can prove that the sum of phi k, where k divides n, is equal to n. This is one of the beautiful properties of Euler's tangent function. This property will be used in the following lectures in order to study prime numbers.